Thanks for joining all. We're just going to give it a couple minutes to get started. Thank you for joining, everyone. We're just going to start things off with a quick ad from our sponsor in just a bit here. And hello, everyone. Welcome to the 2021 CxEnergy virtual webinar series. And special thanks to TSI for sponsoring this presentation. Before we start things off today, I just have some general housekeeping notes to address. In order to receive a certificate of completion, you must be a registered attendee and use the personalized link that was sent to your email address to join this webinar. That doesn't include a link that may have been shared with you. Once each live presentation concludes, you will receive an email with your certificate within 24 hours. And please note, we're not using the CxEnergy app this year. Some of you may have remembered it from 2020. Additionally, and this note is for ACG, EMA, and ABC members, if you're certified CxA, EMP, or TBE, staff will be uploading your certificates of attendance to your respective member portals for you. This will be completed after the final webinar series webinar at the end of April. All live webinars are being recorded, so if you happen to miss one, you'll be able to view it 1 week after the live event. And then during the session, we do encourage you to submit questions at any time. Please don't hold them back. Please use the Q&A button to do so. The chat function is where you can make general comments and chat with attendees. And if you happen to be experiencing any technical issues, use the chat function to inform the panelists, and our technical experts will assist you. So getting into things, the webinar today is all about developing a building envelope commissioning program, and a few words on our speakers with us here. Jeff is a project manager and building performance program manager for the state of Utah, Division of Facilities, Construction, and Management. He has a background in energy management and construction project management with an education in architecture. And Stevan is a building science and sustainability specialist who focuses in passive design, material resiliency, and energy efficiency, which help create sustainable and durable buildings that give more than they take. He serves as the building envelope commissioning practice lead for Morrison Hershfield and has provided building science expertise on high-performance building projects in the US, Canada, South America, Europe, and China. And finally, Rick also works at Morrison Hershfield in their Dallas office and specializes in the design, construction, and rehabilitation of building enclosures. He has consulted on existing and new buildings throughout the world. So without taking any more precious time today, I'm going to hand it off to Jeff to kick us off. Jeff, take us away.
Great. So as I start scanning through these introductory slides, Rick is going to take a second just to give an overview of our presentation.
Okay, great. Yeah, thank you everyone for joining us. Hopefully you have some good takeaways from the information that we're going to share today. So my friends, Jeff and Steve and I will provide an outline to what we've learned over the last several years on providing maximum value through building envelope commissioning. And I think that we're going to try to look at that from kind of two different perspectives. One is kind of the project framework within kind of the program and the process, and then also look at the technical aspects of building envelope commissioning. And again, the overall goal here, I think from our standpoint, is just sharing some things that we've learned that tend to add value, right? And so we don't want to work on projects where there's limited value to the building or to the owner, or even perceived limited value because the process was not effectively set up and implemented. And then also kind of the technical aspects of that within that project framework, I think can also maximize value for owners. And so with that, Jeff's going to get us going here with some background history on some really cool things that the state of Utah has done over the last couple of years.
Great. Thanks, Rick. Yeah, so as was said, my name is Jeff Wrigley. I work for the state of Utah, Division of Facilities Construction and Management, and specifically in the Building Performance Program. And the purpose of my part of the presentation is to briefly tell you all about our building performance efforts, specifically around enclosure commissioning, and provide some context around it, and give you an idea of how we got where we are, because this has been a process over many years, and trying to reach that value is an ongoing effort. But hopefully I'll be able to show you how we do get good value out of our commissioning teams, and hopefully trigger some thoughts of what you can either do to promote effective envelope commissioning or improve your own programs. So just to give an overview of what we do with DFCM, or the Division of Facilities Construction and Management. We're a centralized agency for the state of Utah. We provide professional services to assist state entities in meeting their facility needs. And so we have two basic roles that we fulfill. We manage construction projects, both in renovation and capital improvements, and we also manage new construction projects for state-owned facilities. And then also our agency maintains and operates many buildings throughout the state. We're centralized, and we believe this brings a lot of value to the state, mostly through the consistency of our standards and how they're applied. And then we also feel like we're pretty cost effective and efficient in how we deliver those services. So as I mentioned, there's two main groups within DFCM. There's their facilities management side and the construction management side. And then I'm part of the DFCM performance management group. And we kind of fit right in between and serve both sides. And the goal of our program, as well as the goal of DFCM in general, is really to save taxpayer dollars. But we save taxpayer dollars through making buildings more efficient, making them perform at a high level, And there's other things too. Energy is important, but we also look at maintenance cost. We also focus on space utilization and employee productivity through well-being and comfort. We work with facility managers to help improve existing buildings. We collect data. We try to analyze systems and find ways to improve them. We work with our capital improvement project managers through finding ways to optimize renovations and capital improvements. And anytime there's mechanical systems or electrical systems, we try to get involved, help bring in consultants and experts to make those better. And then we support our capital development project managers by the same thing, really. We bring in consultants and try to improve and make the most efficient buildings we can. So, a quick introduction to the performance team. So I'm the tall guy in the picture. Next to me is Sarah Bull. She is our director of our group and a great advocate for all the different things that we do within DFCM and also within other state agencies. Also pictured is Kat Bartolini and Sean Patrick. They're also involved in project management. And not shown is George Sutherland, who does facility condition assessments and audits. We all work on projects of our own. We have many mechanical upgrades, lighting upgrades, different things we do that have an energy or performance focus we manage. But then we also all have focuses of our own. Kat focuses on space utilization. Sean focuses on data collection. And I focus on new construction and capital development. And a big part of our capital development work is our high performance building standard. And so this is really key to understanding our approach to envelope commissioning, which of course this is about today. So I want to take a minute to explain the high performance building standard and how it's intended to work. The HPBS that we call it is our roadmap to success, and it outlines our expectations in a variety of ways. So over the next few slides, I'll break it down, and hopefully you can see how commissioning falls into the overall scheme of things. In general, the HPBS is a standard. It's part of our DFCM design manual, and it's very LEED-like, as you will see, but our focus is a little different. The requirements have been narrowed down to the design strategies that we most commonly use, and we don't have a point system, but the areas of focus are very much like LEED. And I will point out that we haven't abandoned LEED. There are many projects where the agencies choose to follow LEED, especially with our higher ed institutions. And in those cases, the high performance building standard and the LEED very well function together. But the main thing that we really are focused on with the HPBS is an integrated design process, and we look for participation from all of our stakeholders. The goal of the HPBS really is to spend money wisely during design and construction. We like to talk about sustainability. We all, really want things to be as sustainable as possible. But when we talk to a lot of legislators and different people within the state and agencies, we find that cost is the driver. And so we focus on cost. We want to reduce the overall cost of ownership over the life cycle. And life cycle cost is an important key to the high performance building standard. But we aim for performance in a variety of ways. We're looking for optimal space utilization. We want durable systems, durable materials, things that will last. We really want a tight envelope. That's something that's evolved over time and the importance of it, and we realize it. And in the end, we really want buildings that support healthy, productive employees. And all of these things help drive costs down for the state. Some of the notable elements of the high performance process is we look for workshops at each stage of design. We try to bring everybody together. We want facilities management involvement. The people who are going to live in and operate the buildings are critical to the success of a project. And we have our consultants. The high performance building standard outlines 3 primary consultants. That's the energy modeler, the systems commissioning agent, and the building envelope or building enclosure commissioning agent. And we look for project long involvement from these consultants. And everybody is a resource to the project. And the consultants are really the hub of that. We, in the building performance program, are not engineers. I think we're more project management and program management specialists. And we want to see this process go through very smoothly and with a high degree of success. And really that comes down to those consultants that we bring on board and relying on the expertise that they bring. And a lot of the program development that we've seen over the years has come as a result of fantastic input from our consultant teams. We have great relationships with them and really value their input. So getting into, and I'll just quickly go through this just to kind of give this context, but the various sections of the high performance building standard, again, are very LEED-like, but we have specific sections addressing community-oriented design, transportation management, site design, material impact reduction, occupant wellness, education and outreach. We have pretty detailed sections covering what we expect out of energy modeling and systems commissioning and enclosure commissioning. And then we also address water use, metering, fault detection, and equipment purchasing. So moving on, I'll talk a little bit about the development of the high performance building standard. So it started back around 2005. I say ish. I was not at DFCM at the time, and I've talked to a lot of people, and this is the stuff that I've learned. But back originally, when we first got started, the standard was supported and backed by legislation and a desire to promote those energy cost savings and efficient facilities. And obviously, or most likely, I would say that this was all influenced by LEED and things that were going on in the design community at the time. But looking back at the original high performance building standard, it was actually called the high performance building rating system. It really didn't say a whole lot. It was fairly brief. There was a lot of flexibility in it, probably too flexible, a lot of may and might and should sort of language. And at that time, commissioning was included, but it was very limited in its role. And so over time, we looked to update the standard, and a lot of pressures contributed to that. Really, there was a lot of interest within the state coming from the top. The governor at the time was very interested in energy efficiency and cost savings. And there was a lot of push for higher than code standards. And then a lot of projects were pursuing LEED, and it kind of made it sense to look towards LEED to drive the standard. There was a lot of, the design community, understood the language of LEED and and so it was decided at that time that we should move to LEED, and LEED 2009 was adopted as the standard. So at this time also, while these changes were happening, enclosure testing began, and it really was a result of actual issues in projects, and was promoted and pushed by project managers, because they would see that the problems after the buildings were completed and occupied really needed to be addressed. There were problems with pressurization. There were problems with effervescing and vapor kind of moving outward. We're a very dry climate here in Utah, and so there were a lot of issues that were popping up, and it was seen that some focus or attention really needed to be paid to the building envelope. And we really give a lot of credit to the project managers in our group who were really looking for practical solutions to the issues that they were facing. And they began to look for consultants to help solve the problems. We were bringing on envelope consultants to look at specific things, and also as this was happening, the project managers, since they're one of their charges is to make sure projects are on budget and our costs are under control, they began to really look at how these consultants should be brought on board, what their scopes of work should be, how to specify commissioning, how to specify envelope testing, and how to make it impactful and have value. So a lot of this led to the next update of the HPBS, which happened around 2015. As the consultants got involved and we started pursuing and looking at envelope in particular and commissioning, a lot of study went into it. There was a lot of interest even from like our energy modelers. We had some really good eager energy modelers who were really willing to help look at the costs of improving envelopes and the costs of what how all the costs came together. And our project managers are open into applying stricter air leakage standards. So the person who was in my role at the time, he explained it to me basically saying for a couple of years, they really played around with it a lot. They brought in a lot of different consultants. They really focused on learning as much as they could about, in particular, envelopes and what could be done. There was some pushback, but over those couple of years, they really kind of dialed things in, and that led to the next version of the high performance building standard, which dropped LEED. We felt like LEED was evolved enough and understood enough, and we kept seeing a lot of the same things pop up. So LEED was dropped, and then enclosure commissioning became a big part of it, with a really strict performance goal of 0.1 CFM per square foot of surface area. So and to back this decision, there was, there were numbers that were crunched. Like I said, our energy modelers got involved. And here's just some of the results that came from that. This graph here shows a number of buildings and the modeled results from going from a 0.8 CFM per square foot standard, which is the blue bar. This is energy savings, to sorry, that's the red bar, to 0.1, which is the blue bar. And so we could see that we could double our energy cost savings by improving that standard to the 0.1 CFM per square foot. And this is another graph just illustrating the kind of savings that we were seeing as possible. And so now we've moved on to a recent update to the high performance building standard. And it's in a lot of ways very similar to version 3, although better refined. And really the next move is looking at performance measurements. We want to look at more results and measure. Now that data is becoming more and more accessible, we want to see how the buildings perform in their years after construction is complete. And so as I move towards the end of my part of the presentation, I'm going to dig just a little more into building envelope commissioning and what our program is and the processes that we follow. And like I said, this is all developed over the years, but we really feel like we've found a really good spot. So key to this, of course, is our consultants. Like I said before, we're not experts. We know a lot, but we're not experts in any of these areas. And so we look to our consultants to bring the expertise. They know the ASTM standards and all the different things that go into envelope commissioning. And although our high performance building center does reference those things in some places, we really try to focus on what we are asking our consultants to do. And we're focusing on integration. We want active involvement from our consultants to work with the architects and engineers and contractors, and also us and the agencies. We really look for excellent communication as our consultants work and our commissioning teams work with the contractors. It's really important that there's a good understanding of what's needed and how things can improve. And then the HPBS also outlines kind of the process. I won't go through all of this, but it's outlined. We want different things at different stages of the game. We're looking for design reviews. We want submittal reviews. All of this stuff is laid out. However, we really want things to be flexible. We want them adaptable. We want our commissioning teams to be able to react, I guess, to the conditions of the project, to the needs of the teams, and fit their approaches to that. We want consistency in how things are done, but we don't want a cookie cutter approach. We know that not one size fits all, and each project needs to be addressed based on its own needs. And a huge part of this is the owner's project requirements, or OPR. This is something that is mentioned throughout the high performance building standard. It's something that the architect manages, but we demand input from our commissioning agents to help shape this, to help understand the owner's requirements, and to record these things in the OPR and make sure that those things are followed through all the phases of design, and that they're all updated throughout the project. And really, again, the value comes from understanding the building, understanding its purpose, and understanding the agency that it's going to serve and what their needs are. And a big part of this is how our consultants are selected, a big part of the flexibility. We have two processes that are dictated by statute. One, we can direct award. Anything under $100,000, we can pick the consultants that fit best based on whatever factor. We get a proposal, and the fees are based on a schedule. Basically, we have a fee policy that's outlined in our DFCM standards that gives a range based on the complexity, based on the size and budget of the project. If a project is large, then we have to do a value-based selection. But again, we're not looking at cost. We're not looking at the structure or the outline of what the consultant or the commissioning agent is proposing. We want to see their project experience. We're basing our selections on a variety of scoring criteria that take their skills sets and their experience into account. And this gives us the ability to be flexible. When the project is developed, we can have the commissioning agents define their scope of work, and as the process goes through, as the design is worked through, some things might become more important in the design phase. We might want to decide that different tests are more important, or we might decide that the various focuses can change and need to be adapted to. The drawback is that with the budget being defined, and we may have to trade off, but with different things, but we feel like we found good value and good success. And just real quickly, case study, we did this a few years ago and looked at 2 buildings that were very similar climate zones. One built at an earlier stage of the high performance building standard, one built later, and we saw a noticeable improvement in the EUI and the performance of the buildings. So with all of that said, we'll now transition or move to Steve and his part of the presentation.
Thanks, Jeff. That's some really great stuff. One thing to know about is, we see from a lot of owners is that they just defer to, there's a lot of these programs and processes that are out there published. There's so many of them. It's very confusing, with so many industry guidelines, which one do you listen to? So there's really great stuff in a lot of these, but a lot of these aren't a one fit all for project type or for a lot of owners as well. So when you got to look at this, it's sort of that program versus the process. So DFCM, they had a need, right? And they were trying to address that need, and it took them a long time, which is great. You don't get to it. It's not a race. They're getting to something now that works for them perfectly. So this process, those commissioning processes and standards that are out there can help execute the program. But before we can act, we have to have a concrete plan. And that goes into the importance of what Jeff just said about the owner's project requirements. They're often, thought of as last minute. They're usually cut and pasted from previous projects. A lot of the times you can't really get that benefit from that. This has the potential to have a huge impact over the design and life cycle of a project for an owner. So when an OPR is developed, basically it's their roadmap. You want to keep it as a living document. It's going to be great for all the project stakeholders, provides a document for the service life of your project. And it'll apply for any modifications. And I find a lot of the times having a really good, thorough owner's project requirement, you can capture a lot of the things that maybe you couldn't do in design documents or as-built documents. One of the more important things to look at, though, is that to make sure that the owner's vision is actually what the team's vision is. So that document can help us sort of like translate, of what the owner actually wants from a performance or even prescriptive requirements to the design team to allow them to have a clear path on what the owner wants when they're coming into design. You want to do it early. These photos are in here just as sort of as in jest, but the funny thing is that these were actually built, right? So you want to make sure things are set up as early as possible to avoid any ambiguity. Right now, when I see from a building enclosure commissioning agent perspective, a lot of the OPRs lack the right amount of clear information, especially related to the enclosure. A lot of it, they do have some good MEP requirements in there, but a lot of them just seem to miss it on envelope. So on the screen here are some of the requirements that you can include into an OPR. A lot of different state codes or city codes driving up energy and high performance, resiliency and carbon, right? There's a lot of these things that are now starting to get added into OPRs that may not have been added, 5 years ago. So it's great to have these things in here to establish that clear set of performance requirements to give you basically delivering a higher performance building. And a few of the things I wanted to highlight in here is that, you have budget and durability. A lot of the times when you start looking at the budget, as Jeff said, especially with public and state entities, cost is always at the top. But you got to look at cost and not have something that will then deter something on their durability requirements, right? So a lot of the times these VE options come in and you just want to make sure that it's not at the effect of lowering a performance that's in the OPR. as well as one of the things that I liked about the DFCM is that they actually use their OPR to direct sort of what they're doing into, post-occupancy, into the operations phase. So rarely do you ever see that. And so you look at what's important to the owner and, how to ask the right questions and have the right people in that room to make the right decisions. You can start these out with having some high-level needs of the owner, looking at the occupants, the facility managers, everything, and don't be afraid to include any restrictions or limitations. And a lot of these things should not be confused with architectural programming, which a lot of projects use the architectural programming as sort of their OPR. That architectural programming is when, architecture begins, but if you could establish, the owner's commissioning or performance program much earlier than that, then you'll have a clear set goal getting into design. And then you can drill down into specific objectives. Once you lay your high level things, you can drill down to a lot of these things. One of the things, to ask them about is sort of their maintenance requirements. Are you putting something on the building that, is the facilities guys expecting to just do, their preventative maintenance off a ladder, or do they need to have swing stages or, have lifts involved and things like that? So it's looking at the maintenance expectations for the life cycle of that building. One thing I just wanted to touch on too is just, we have a lot of owners that they think, we'll just let lead handle it, right? So they just require, just meet lead. And so one of the things, there is a bit of disconnect between lead and what could be in an owner's project requirements. Lead only requires certain systems to be commissioned, where in your owner's project requirements, you may have more systems, more aspects of the building that the owner wants somebody to commission or look at. So, there's that disconnect. And there's even a bigger disconnect when you get into the prerequisite with lead, because from a building enclosure perspective, all they want is that there's enclosure in the OPR, a basis of design review, and one design review. And that's it. That meets the lead prerequisite requirements for building enclosure commissioning. However, what happens if the OPR actually requires more testing, more performance, things like that? Who's going to do that past that, for the rest of the design, into the bidding phase, construction, and all that? So that's one thing to look at, is that don't just think a document out there is going to cover all your bases for you. And this one is just sort of, the overall of an OPR development process, through design, construction, and operations. Again, one of the things, it's a living document. So, through these phases and at the end of each phase, at the minimum, they should be updated to match what is actually going on. And one thing I always try to tell project teams to consider is that, during those VE phases, during construction, and the submittal phase, is to keep the OPR in mind. You're not just going to approve something just because it comes in a little cheaper. Are you doing that at the effect of something else from a performance perspective? Sometimes there's no change and no effect, but it's just something to keep in mind, that that OPR should be with you in your mind through all these different phases in the process. With that, I'll turn it over to Rick.
Great. Thanks, Jeff and Steve. Okay, so in our last 15 minutes or so, we'll kind of close out with some technical specifics within the state of Utah's program, and also some key technical points that I think that may be helpful for envelope commissioning practitioners, but also for owners looking to gain maximum value from an envelope commissioning process. I think one thing that I like that the high performance building standard does is it categorizes building types into two types that require different levels of commissioning. Fundamental level, which is a more basic program, and then enhanced, which is a little bit more complex with more stringent performance requirements that need to be met. And so based on the state of Utah's architectural project complexity and budget, they've kind of set out, hey, along this line here is where we're going to start making these buildings require the enhanced, more robust program. Anything less than that can do a more basic or fundamental approach. Within the guideline itself, I'm just going to point out a couple things. I know this is a lot of words, but I've kind of highlighted a couple keys that I think contribute significantly to the state getting maximum value out of this program. Is that the one thing is that the building enclosure performance criteria must be reconciled with the project specific energy model. And so what this is trying to get at is really creating some reconciliation and coordination between the energy model and the building enclosure performance, specifically things like air tightness and thermal performance. The other interesting thing that the high performance building program requires is that spandrels must be insulated to the opaque wall minimum insulation requirements. And if not, it has to contribute to the state's 30% glazing ratio. And so what we've seen is some people kind of skirting around a requirement that spandrels do need to have high performing thermal performance, but realistically not getting even close to the opaque wall minimum in terms of thermal performance because of thermal bridging that's not accounted for. In terms of air leakage, the enhanced buildings require a very tight building envelope, an air leakage rate of less than 0.1 CFM per square foot per ASTM E779. And then what I'd like about the program too is that it allows the buildings that fall within the fundamental category actually to identify a project specific air tightness that's based on the project specific energy goals. And so I think that that gives you a lot of flexibility in some of those smaller buildings to take kind of a project specific analysis. So it's creating some structure where we've confirmed that structure is needed and we know what the goal is, and then also allowing for some flexibility in some other types of building projects that may not benefit from or achieve maximum value, right, from such a tight building envelope as kind of the larger buildings. I think recently there's some great progress on thermal performance requirements. And so the effective thermal performance must be reconciled with the energy model and the mechanical engineer. And so what we found is that thermal performance on buildings is significantly overestimated. I think that, you know, a typical building where we think we have a wall assembly with an effective R15, I think realistically is around an R5 to R7. Just based on projects that I've worked on recently, when you start accounting for thermal bridging. And a lot of that thermal bridging is historically neglected. And so I'll get to this a little bit later, but I think that when we realistically look at thermal performance and show that on the energy model, it allows us to make improvements to the envelope that actually increase energy performance. And then finally, the state of Utah in their thermal performance requirement says that if you have an assembly where the thermal bridge does not contribute to heat loss of more than 10%, then it can be ignored. And this is kind of a way that we don't make the thermal bridging requirements overly burdensome for these projects where people are just now starting to look at the impact of thermal bridging. So moving into kind of water, air, vapor control, most of the state of Utah projects use kind of backup wall, exterior insulation, and a rain screen cladding, which I think has given them a lot of good high performing buildings with good durability over the last couple years. As you can see, you know, there are a lot of things we need to be looking at with the membranes. The fluid applied membrane, the photo on the right, obviously is too thin. And so this is something that we're looking at during construction phase, making sure that the installation is performed per the manufacturer's requirements. Compatibility is also a big thing that we look at. So here we have an example where another manufacturer's self-adhering through-wall flashing was sealed to a different manufacturer's air-water barrier, and the sealant wasn't compatible. And so you have this very critical interface at the bottom of a wall. If you don't have good sealant adhesion at the top of that through-wall flashing, there's really a significant risk of water penetration. So these are some of the things that we're paying attention to compatibility-wise. Horizontal conditions, there's actually a lot of kind of good discussions on vapor permeability of horizontal air water barriers, and especially coming out of kind of the Pacific Northwest right now. And so we want to look at these in terms of permeability and also waterproofing, right? And I think, yeah, there's just some good research out there that is looking at these things, especially kind of rough openings where you return the air water barrier into a rough opening below a window system. And traditionally, we're thinking that some of these small areas would benefit from an impermeable membrane, but there is some research out there showing the benefits of allowing that to dry to the exterior, and kind of suggesting that a permeable membrane may be advantageous in some of these types of conditions. So I think that that is really helpful. There's a lot of good research in the building enclosure industry right now that we really are trying to apply to a lot of our projects that we're working on. Real quick on roofs. So one thing I think that's really important is that all VE options that are brought to the table need to be evaluated by the building enclosure commissioning agent on these projects. And the intent of this is not so that we can come in and say, hey, no, we don't want to do this. It's really so that we can provide realistic advantages and disadvantages of the VE option to the owner so that they can make informed decisions, right? So roofs, for example, a lot of times people will come in with a metal deck and say, hey, can we get rid of the substrate board? We have an air vapor barrier that can be applied directly to a metal deck. So what are the risks here? So as you can see, someone drops a hammer on it and puts a hole in it, right? And so can it be repaired? Absolutely. Will it always be repaired? That's unknown, right? And so some of these are the disadvantages that we would give the owner in that type of a VE scenario. And moving on to thermal. So thermal bridging is basically any highly conductive material that bypasses the insulation layer. So we often think of steel framing within a opaque wall where there's batt insulation placed within the steel framing. And so what you can see here is you have a lot of thermal bridging. And so traditionally in the industry, there are ways that code allows us to account for this type of thermal bridging. We worked on creating a building envelope thermal bridging guide over the last couple of years with some partners shown on the slide. And basically, we've provided this guide that gives project teams really easy ways to quantitatively identify effective thermal performance that accounts for thermal bridging. And so what we have here is kind of a realistic building envelope analysis where we're looking at all types of conditions within the clear field of a wall or within linear interface conditions like parapets or shelf angles or glazing perimeters. And now we can take this guide and very quickly and accurately identify what the effective thermal performance is. And so when we look at a typical masonry wall, for example, we may have an assembly that has a nominal R16.6 thermal performance, but we start reducing the effectiveness of the insulation once we add in masonry anchors, shelf angles, parapet conditions, window perimeters. And so now, due to the thermal bridging, we're actually at an R7.7. We think it's really important that project teams use the actual thermal performance rather than the nominal or even minimal reduction in effectiveness that accounts for some thermal bridging, because it doesn't quite get you to where you need to be. And so the reason I think that this is so important is because we worked on so many projects where we have an energy modeler who says, hey, we have R15 walls, we're good. There's really no value in adding any insulation or addressing thermal bridges on the project. Let's look elsewhere for how we can improve our energy performance. And so I think that we're missing out on a huge part of realistically adding value to wall assemblies because of the overestimation of that thermal performance. And so when we realistically look at it, we're probably more at an R6 effective, right? And so once we start improving from R6 maybe to R10 or R15, then we actually have some pretty good improvements. But yeah, we would agree that if we're going from R15 to R20, maybe the value isn't there. But I just don't think that we're there on most of our projects. And here's another scenario where we kind of look at payback of different options, right? And so we have the baseline wall assembly. You can see much more energy use than the code requirement for this example of a maximum U factor of 0.064. And we start looking at the payback of different options. But once we start looking at multiple options combined, and improving various components, kind of pushing through looking at one particular instance, we actually get down to areas that have expensive quote unquote technologies into the 18-year payback range, which may be something that is more palatable for project teams rather than comparing to, hey, just adding more insulation, which is a 54-year payback. Yeah, we would agree. Probably not helpful for a lot of projects. Just another comparison here between a metal panel wall example, right? So can we use 4 inches of insulation and get an effective R13.1 with continuous metal girts, or can we use thermally broken clip system and use 2 inches of exterior insulation? And so these are the things that the state is really looking at carefully to kind of very thoughtfully and use a cost-effective approach to kind of building up the wall assemblies. Steve, did you want to chat about this one?
Yeah, this is just another one to reiterate. This was a project in Portland, Oregon, where we had the spandrel area, so the non-glazed areas of the curtain wall had insulation in front of the metal back pan. And so the design team thought, hey, we can create a really great additional energy efficient building with all this space that's in behind the back pan in that little metal stud cavity where the drywall is, between the back pan and the drywall. So in looking at that, there is enough space to add about an R11 worth of insulation with spray foam. But when you take into account a lot of the metal angles, the lineal transmittance and point transmittance of thermal bridging, if you don't account for those, simply adding in spray foam, you can see here from the graph, adding an R11 actually only got you an R4's worth of increased performance. So that's something to consider, as you're looking at projects. More is not better in all cases. So, is it better to spend all this money on something expensive like spray foam, or should we look at using that money, to come up with some other cost-effective ways to increase the energy performance?
That's great. Thank you. Secondary structure. So engineering of kind of claddings, components, and roof assemblies is something the state has also looked at including into the envelope commissioning program. And so, yeah, I just don't want us to think that this needs to be limited to air, water, vapor, thermal. It really can include any level of other types of components that need to be looked at that the owner wants to verify the performance of. And so you can see, hey, we're commenting on kind of deflection limits and things like that of a curtain wall system because there were some previous problems with curtain wall systems in the engineering aspect. So yeah, lots of good things I think coming from that direction. Let's look at designer views a little bit. I think that this is really important for us to understand in terms of adding maximum value, right? So value added decision is something that the state's looking at doing on a lot of these projects. And so it's like, let's look at all the options, look at the pros and cons, look at the schedule, workmanship dependency, performance, durability, cost, all these different things. And let's together collectively decide what works best for the project. And the great thing is we're making a lot of these decisions very early on in the design phase. Moving along here, I think understanding the plane of the building thermal envelope as well as other interior non-conditioned spaces is really important. And so a lot of times we'll in a very detailed way, go through the plans, building sections, and make sure that we understand what each environmental separator is really responsible for doing. And then when we're getting into the details, yeah, we're really looking at, hey, what are these primary control layers that we care about, and how are we demonstrating continuity of these control layers? And then field verification is critical. The state usually uses an on-site standalone mock-up for their projects that's reviewed, tested, and approved prior to construction on the building. A lot of the field testing is pretty standard field testing in my experience, a lot of kind of water spray rack testing or air leakage testing. And I think we get creative too with not necessarily needing a full-on chamber test at a lot of areas. This was just a challenging expansion joint transition down the wall onto a through-wall flashing that we just wanted to spray with water. And so something like that, I think, adds a lot of value to a project without adding much cost. And then field observations, right? We're not only looking at the materials and how they're installed, but we're looking at the complicated transitions. And so these are inevitable in every project. You have, some odd transition that maybe isn't included in the design documents that we need to look at and make sure we are addressing appropriately in the field. And so just to close it out, I know we do have some questions that I want to make sure we get to. We just want to help the industry by sharing our experiences in the hope that envelope commissioning agent providers can continue to work with project teams and educate owners, educate the industry on, hey, how do we get the most value out of this program, right? And so we want to kind of tailor that to each project to make sure the building gets what it needs, right? And then the building envelope commissioning providers really need to work with the client to make sure that there's some thoughtfulness that goes into the building envelope commissioning scope. And then I think there's always an opportunity for increased coordination, especially from the building enclosure side, because in my experience, historically, sometimes we're kind of left out of the discussions with the HVAC engineer or the energy modeler. And I think that there is a lot of value when these groups can come together and reconcile performance goals and realistically look at what the building envelope is doing. And then I think it's good for us to understand what tools are available in the industry, because I think that tools are allowing us to quantify building performance early on in design, whereas previous years, I think we were going a lot on just kind of experiential data, and kind of what worked and what hasn't. I think we have some good modeling tools that can help us with a lot of these goal defining phases as part of the project. And so, yeah, with that, we'll close it out. And yeah, we'd be happy to answer some of the questions that came in.
Okay, thank you so much to the three of you. That was great. Bleeding into the questions, one's right by a building owner. Here we go. What are the top 3 requirements that you would like to see in an OPR for building enclosure? And what information would help an owner provide informed decisions?
That's you, Steve.
I think having them, you don't want to be too prescriptive in OPRs, because then you end up sort of cornering design teams into a corner without allowing them to have using any of their innovation or creativity. So I think if you can try to look at from an enclosure commissioning standpoint, look at your roof, your windows, opaque walls, all those systems, and come up with, primarily we're always looking at the 4 barriers, right? Your air, water, thermal, and vapor barrier. So coming up with sort of a set performance requirements for each of those at minimum will allow design teams to move forward, but then also allow owners and commissioning agents to sort of have something there to use as sort of checks and balances to make sure you're meeting those requirements. And a lot of those things can then get informed into the energy model correctly.
you so much, Steven. So I think, Rick, you may have touched upon the first part of this question, but it's multi-part. So let me read this one off. Is thermal imaging required as part of the building enclosure commissioning process? And when is the best time for this to be verified? After HVAC has been installed and operational building has been sealed up?
Yeah, that's a good question. I'm not an infrared thermography expert. I actually have not personally relied on it myself a whole lot throughout my practice. I've used it much more in a diagnostic approach. And so to answer your question, the state does not require thermal imaging on their project at the end, unless it has not met the air leakage goal. And so if, based on kind of observing the design and construction, we should have a good sense of thermal barrier continuity. And so we're really only going to use it at the end of the project to identify air leakage pathways if it does not meet that goal. Most of the time, the way the program has been set up, we actually haven't had to rely on that to identify the goal, because the buildings that we've worked on have been so successful in meeting the air tightness goal that we actually haven't used infrared thermography too often in having to kind of diagnose where we're losing air during a pressure test. In terms of when it's performed, HVAC, I think you need to make sure, from my experience, you want to have the right air temperature difference, right? We usually want to have at least 15, 20 degrees minimum difference in exterior and interior air temperature. So if that requires, needing the HVAC, then obviously, then you would need to do that. And then I think that using some air pressure difference, if you're diagnosing an air leak, is very, very important. I personally have not used mechanical systems too often for that, because in my experience, I haven't been able to get the air pressure difference as high as I would like. And so usually I won't rely on the HVAC to create the air pressure difference. I will rely on a blower door to kind of create that air pressure difference. So yeah, hope that answers your question.
Thanks, Rick. So I have two questions on thermal bridging that I'm kind of put together. Can you show some practical ways or details to address thermal bridging? And then also, has the impact due to thermal bridging been quantified in field testing, or is the issue purely analytical?
Yeah, that's a good question. In terms of kind of conceptually seeing the thermal bridging, I would encourage you to download the BC Hydro thermal bridging guide. You can go to the website and download it, and it'll give you kind of 20 pages of how to use it, and then lots of examples in the appendices on actually quantifying the thermal bridging. In terms of the state projects and field testing for thermal performance, we haven't really had to do it. Most of the state projects that I've worked on are pretty traditional off-the-shelf assemblies, where we kind of know the thermal properties due to product testing, and then we combine that with the thermal bridging guide that allows us to kind of find a very, very similar detail. And using our judgment, we've been able to determine that we think that is getting us close enough. On some projects, certainly you're looking at, kind of mock-up thermal performance testing. A lot of that, is done in a laboratory. Certainly there are ways to do field thermal testing, but on the things that I have seen recently, I haven't seen a whole lot of value in looking at that and that level of testing. So
I'd mentioned that in the thermal bridging guide, all that 3D modeling has been confirmed with constructed lab tests to confirm the amount of heat transfer related to those types of details and materials. So that the stuff in there isn't just purely spit out from a computer program. It's actually been confirmed through construction and testing in a lab.
Mm-hmm. That's true. Thanks.
Thank you. Okay, next question up. Data centers. Does anyone have any experience with building enclosure commissioning in data centers? And if so, what do you have to share?
Yeah, I was going to say, Steve, I think you've done some work recently, haven't you?
Yeah, and there, so there's a few things there. Is just that thermal envelope is huge just because of some of the spaces, right? Of the, high heat and then the cooling loads. One thing I tell people to consider is that when you're doing enclosure commissioning for data centers, think of everything as an environmental separation. So you're not just, some people just focus on the exterior walls and roofs, but you may have some of these high heat areas next to, is there somebody's office in there as well? So that interior wall or floor or ceiling where you have very different environmental conditions, if you don't treat that sort of as like an enclosure wall system, looking at it from a thermal or air leakage perspective, you can get into a lot of trouble. In one recent one, they had in the ceiling space, basically right below the roof, they used that as their plenum for exhausting all the heat. And then a fan would kick in to try to exhaust some of that heat in certain times. And we noticed that in the winter time, it was kind of funny. On one side of the roof, there was a lot of condensation, in the mornings or the cold, wherever any metal I-beam that came in from the structure that bypassed the insulation, it would have condensed on that, but not on the other side. And basically what it was the side where there wasn't condensation had a PV array covering that whole side of the roof. So basically, during the winter time, the night sky radiation will make some surfaces colder than even the ambient air temperature. So where they're trying to exhaust that air, if you have some fresh air from the outside come in on that side of the roof that didn't have the PV was taking the brunt of that night sky radiation, where the other side, it was the roof. So you had some ambient air even coming in from the outside and condensing as well. So it's just little things to look at, but the thing is just to make sure that, you consider anything with dissimilar environmental conditions as an environmental separation. So you don't almost treat things all as an envelope. And for those ones, air and thermal barriers are very important in those project types.
Awesome. Thank you so much. And then this next question, Jeff, I did believe it came on kind of early on during your section. How did you quantify dollar savings when reducing infiltration to 0.5 and 0.1? What testing and measuring was done to determine what infiltration was at the time of the test, and how was the reduced rate converted to a dollar amount?
Well, I wish we could say we did extensive testing to come up with those numbers, but those numbers were based on energy modeling, just looking at how the different infiltration rates impacted the energy model and then the resulting cost savings.
Okay, thank you so much. We have two more questions I'm hoping to get through before we end things up here today. Next question, someone's wondering, have you applied building enclosure commissioning to existing buildings, and when does it make the most sense, and what testing is helpful?
Well, so from our perspective, we've not done what I would consider full-blown envelope commissioning on any kind of renovation work. However, we do employ our consultants quite often if we have extensive like reglazing or any sort of exterior systems, and even on roofing projects. We've had our enclosure specialists actually do design work for us and consult in various ways. But we've not actually done like any whole building air testing or anything like that. Probably any testing done would have been limited to water tests or things to show that the seals on the various elements were good.
Great, thanks, Jeff. Final question here. Do final building pressurization requirements come into play when you're testing completion? And they put in some examples: outside air or positive building air quantity differential. as energy cost of conditioning that needed differential for operation should be considered. Is there a minimum CFM per square foot that you can place for a well-sealed building?
Yeah, I think I'll take a stab at this, but I will warn you that we're getting into, mechanical systems, which I just know enough about to kind of understand how the enclosure needs to be designed. And so, yeah, I think that we have had some issues while we were doing a whole building air leakage test with kind of mechanical systems, right? And penetrations and things like that. And right now, the way the industry approaches that and the way that we've done this on State of Utah projects is we're trying to kind of ignore intentional penetrations through the envelope, whether those are, open air plenums with a louver directly to the outside, or, ductwork or some other sort of mechanical related penetration that could contribute to air leakage when we're doing a whole building air leakage test. And so, what we do is kind of follow ASTM 779 is we are neglecting intentional penetrations. And so from an envelope perspective, we're really only interested in determining that CFM per square foot at the 75 Pascal air pressure difference.
Thanks so much. Jeff, Rick, Steven, thank you so much for coming on today and sharing and telling us about your project. Awesome. For all of you still on, I just want to note that next week we'll be coming back here Tuesday, same time, to talk about how commissioning professionals can navigate evolving building energy codes. And then also tomorrow we have a technology demo day. This is free. If you are registered for the entire CxEnergy series, you should have seen an invite. If not, head over to CxEnergy.com, register for free. We got 6 exhibitors lined up to do free demos tomorrow. I'm excited to see you there. Stay safe, stay healthy, and have a great weekend, everyone. Thanks all.